Alright, today we're going to look at Unit 23, Screw Thread Specification. This is probably one of the most important lectures that we're going to cover all year, and I would suggest just pausing right now or whatever you have to do to get you a notebook and make a few notes as we go through this, because this will be a lot of information that will be on your final exam. So we'll go ahead and get started through here. Now, first of all, when we think about threads, we think about what do threads actually do. When we look at the very first sentence of this chapter, it says they transfer motion, they transmit power, and they fasten parts together. I've got a type of thread here that is well known for transferring power. This is an Acme thread. Okay? This doesn't look like most threads that you would find, but this is an Acme thread and it's for transferring power. One place you might see this is on a lead screw on a lathe. Another place that you might see this is on a screw jack. Everybody that drives a vehicle around, a lot of times you got a screw jack in your vehicle for jacking up to change a tire. A lot of the times that thread that's on that screw jack is an Acme thread. That Acme thread is not easily damaged. If you hit it, it's not going to damage it like it does a 60-degree thread, so it's a little bit tougher. And it's just made for a rugged environment like most of your environments would be for transmitting power. But that's a type of thread that would transmit power. Now, we're going to spend the majority of our time talking about 60-degree threads. I've got a bolt here that was actually made in our shop by one of our students. If we come down here, I've got a drawing that I've got made. This thread right here, if I was to take and measure the included angle of the thread, it is 60 degrees. There are many 60-degree threads. You have metric, or 60 degrees. Another thread form that we talk about would be unified threads, and then we also talk about American National. So we'll get into thread form a little bit here in just a minute. The very first thing in our book talks about major diameter or outside diameter of the thread. Now, I'm kind of partial to calling it the major diameter. Your book says outside diameter of thread, but here's what that is. If I was to take and measure across the thread from one over to the other crest, the crest of the thread is up here at the top, I would call this the major diameter. Now, basically, that's the first step to identifying what size a thread is. Alright, we're going to have a thread note that we're going to look at. For instance, they've got a thread note in the book that says 7/8 UN C 2A LH. We're going to talk about what all this stuff means. Okay? I'm going to actually talk about it in relation to my drawing down here. You've got that to go back into your book, but I'm going to talk about my drawing, and we're going to relate it to this part right here. Okay? First of all, the first step in identifying that thread note is identifying this major diameter. We do that by measuring. I've got a set of calipers here. I'm going to turn them on, and I'm going to measure the major diameter. Now, on this bolt here, I'm measuring 992. Okay, that is not exactly 1 inch. It's a little bit under. Your major diameter is always going to be under or equal to. It will never be over. Okay, I've got a book right here, the Machinery's Handbook. This Machinery's Handbook has 1'8" Unified National Course listed here. Okay, we can come over and find all the different things. Now we got to go all the way to the top up here to see the columns. And we got major diameter, minimum, and maximum. So let's scroll back down to the bottom. If you notice, for a class 2A Unified National Course, it's 998 for the major diameter maximum, 983 for the minimum. We measured 992, so we fit right in that. So there we've got our major diameter. That's the first way to identify a thread. We got to come in and figure out what the outside diameter of the thread is. The next thing we're going to do, we're going to measure 1 inch. And we're going to count how many threads are in that 1 inch. Now, my drawing's not going to be exactly right. Basically, what I would have to do is come over here, find me a steel rule, and I could measure 1 inch, and I could count. I don't have enough hands here. 1, 2, 3, 4, 5, 6, 7, 8. I got a little piece of one there. I needed to scroll it back, but I've got 8 threads per inch. That's one way to check it. Another way is I have a screw pitch gauge. I don't know if you're going to be able to see the numbers on this or not, but right here on the leaflet, it's got an 8 on it. Okay? You see that 8, that says this is a pitch or a threads per inch of 8 threads per inch. I can come right here, stick it down on my part, and you notice that matches up. It's 8 threads per inch. So I can check with the screw pitch gauge. That's the second part of my thread note. So far, we've identified that this is a 1 inch 8. Okay, it's a 1 inch 8 thread. The next thing is thread form. What is the thread form? Well, I told you about 2 different thread forms a minute ago on 60-degree threads. I said one of them is unified, and another one is American National. We'll just put that like that. Okay. Most all of your newer prints and everything will go with unified because they have newer classes of fit and everything involved. American National is what used to always be used. Now, these two will interchange. You can use them. You can use an American National nut on a unified thread. It's just the classes of fit, the way they're labeled, and the amount of flat on the crest and down in the root is a little bit different. That's all the only difference. The fits are still going to be basically the same when they go together. We're going to do a unified. So this is a 1 inch 8 U, and now we also have to figure out the thread series. If you look up here, they talk about thread series. This is our form, and then we go to thread series. Now, in order to understand what the thread series are, there's a lot of different thread series possibilities. Some possibilities for series. You could have C for coarse. You could have F for fine. You could have EF for extra fine. You could have S for special. There's all kinds of different ones. Most of the time what you will see appear on a tap drill chart or a chart that's hanging around the shop, you're going to see the coarse and fine. A lot of times you'll see the N grouped with this. They got in the book here, it talks about UN as unified threads, unified national. But it's UN, and then we put what threads per inch it is, either coarse, fine, extra fine, or special, or whatever. If I come over and look in my machinery's handbook, you will see 1 inch 8 is a unified national coarse. Now, I'm going to have to flip pages. We come here, there's a 1 inch 10, that's a special. You're not going to see that appear on most of your charts, but you will see this 1 inch 12 appear, which is a national fine. So that's some different designations we got to look for. You look down here, you see one there that's inch 20, that's extra fine. Alright, that's more threads per inch. Threads are smaller. So we know that this one's going to be UNC. So we'll go ahead and put the C right there. Now, the next thing we're going to get to classes of fit. I'm going to flip over in my book here. This stuff's already written out. And it talks about unified screw thread classes. And it deals with the tolerances. Okay, the widest tolerance is going to be class 1. We got an A and a B on there. A is for external, B is for internal. We'll talk about that a little more at the end of the thread note. But we've got 1 being the loosest, And then we come down here to class 3A or 3B. That is the closest fit. That's the tightest fit. Okay? And then you got an interference fit. It says that's the former class 5 of American National. American National actually went 1 through 5, with 1 being the loosest, 5 being the tightest. That is some examples. Now, they've got the major diameters and pitch diameters and all that written down here. We're not going to get into pitch diameter a whole lot, but when we talk about how we fit a thread, we don't make a thread tighter by making the major diameter bigger. We make it fit better by changing the pitch diameter, which is actually just an imaginary cylinder that runs through the middle of a thread. And we use like a pitch mic or thread wires or something to measure that. And we refer to that as, oops, if I could write, pitch diameter. Alright, that's what we measure for classes of fit. We're not into cutting threads in here right now. This is a blueprint class. Basically, you just need to know that pitch diameter determines the fit, and that major diameter does not determine the fit. We don't make that bigger to make it fit tighter. Alright, so that gets us back over here. When we talk about, when you see the 2A, class 2 is a good general purpose fit. When we talk about that class 2, that's a good general purpose. That's what you're going to see on a lot of things. Now, I'm going to flip back to the first page. Everything here up to that 2A, this could be the complete thread note if it was a right-handed thread. Right-handed thread, when I talk about that, you're going to think about righty-tighty, lefty-loosey, if you've ever heard that, if you've ever been around working on anything. Now, this thread here that I have, though, a right-handed thread, the nut would go on this way. You notice it doesn't go on. I've actually got a left-handed thread. It actually spins the opposite direction as to what you're used to seeing. So I'm going left and it's actually tightening up. That is a left-handed thread. When you see a left-handed thread, you got to come down and put an LH down here on the end for left-handed. So, with that being said, you need to remember there will be a graphic on or a thread note, something like this, on your test. It will point at this one, for instance. You need to know that that is major diameter. You need to know that 8 is threads per inch. You need to know that the U is unified. Or you could tell me it is thread form. You get down here to the C, that is thread series. 2, class of fit. The A means it is an external thread. External would be a bolt. It would be like this thread right here. It's an external thread. You would produce that by chasing threads on something or using a die. B would be an internal thread. You would produce that with a tap, or you could chase it in a hole with a threading bar, boring bar with the threading tool in it. But that is an internal thread, B. So you could have an A or a B right here on the end. And then, of course, left hand is going to be LH. Don't have much room left on there, so I'm not going to write that one on there. So that covers everything on this first page. It talks about all the stuff on the first page. Next thing we're going to look at, you come over here, it's got more stuff talking about thread form, thread series, and then it talks about the unified threads. And then we get over here, we actually have different forms. Okay? It's got different forms and stuff. You can look at those. And then there's the classes of fit. So that's what I wanted to cover about the threads. The only other thing that we haven't talked about with threads is when we get into screw sizes. Now, I'm gonna talk to